Hello everyone, today we will see how to automatically extract areas based on specific NDVI thresholds from a high-resolution raster image using Python in QGIS. So the video is divided into three main parts. First, we will see together why this type of application is useful. Second, we will go through the script. It is to know that it's a simplified version of the script that focuses on extracting data from a single image, just to demonstrate the basic concept. However, keep in mind that this process could be extended by combining multiple indicators or automating batch processing to build a more complete and complex dataset in the cloud infrastructure for advanced analysis. Third, we will look at the results of the script to see how effective it is, and finally, we will wrap up with a brief conclusion of the tutorial. So let's travel in France, near Reims, in Champagne. Here you can see the Montagne de Reims, located in northeastern France in the Marne department. It's a mixed oak and beech woodland rising to just over 200 meters above sea levels. Just east of the Montagne de Reims lies the chalky Campagne plain, a vast agricultural area. These soils are intensively used for growing cereal, beets and other crops. So why is it important to study NDVI changes over the Montagne de Reims? It is to know that the NDVI helps track the health and vitality of both natural forest and cultivated areas like the Champagne vineyards, which are essential for local agriculture and economy. Studying NDVI over time reveals changes in land cover and vegetation dynamics, helping to understand the effects of climate variability and human activities on these sensitive regions. So this is a satellite view over Reims and the Montagne de Reims. You will see that I have the NDVI image of this RGB view. If you want to compute the histogram, you see that there are some crops that have a high NDVI. So for example here you will see that some crops are cultivated. So for example here our goal will be to extract all the areas where the NDVI is greater than 0.5. So for example this threshold could help us identify zones with healthy and dense vegetations which we want to isolate for further analysis. So basically those are the area with intense green color, and here we will have all the pixels that are located here in the histogram. You can find the Python script in my GitHub, and you can open the Python console in QGIS. So you open a new script and you can paste this Python script here, and we will see together all the steps of this process. So first step, we will have to define the file path. So we specify where our input raster image is located. So here basically this is not my image, the name is this one. So here this is a folder where we want to save the results and the name of the output files, including the thresholded raster and the shapefile. So I will choose these names. The step 2 involves a creation of the output directory. So next we check if the output folder already exists or not. If it doesn't, we create it to make sure we have a place to save our files. The step 3 allows to delete existing output files. So before running the script, before running the process, we can delete any previous output file with the same name to avoid conflicts. The step 4 is a really important step because this is the raster thresholding. So we use the raster calculator of GDAL to keep only the pixels where the NDVI is greater than 0.5. So all other pixels are set to no data, meaning they will be ignored. The step file will polygonize raster. So we convert the filtered raster into vector polygons and save these as a shapefile. with a name that you have already defined. Then we load the shapefile into QGIS, apply a filter to keep only polygons where the value is greater than 0, which corresponds to the NDVI values above 0.5, and display only these areas. So at the end we have thresholded, polygonized and filtered NDVI data ready to analyze inside QGIS. So we can run this process, and after a while you will have your polygonized cleaned data in Shapefile. Okay, finally, after a while, it took me like 5 minutes for a Sentinel-2 tile. So I will remove the previous test. This was this one that have been generated by the script. So here we can replace the opacity to see the results. Maybe I will set it like that, and I will improve this. Great! So I can close the Python console, and we see that the thresholds of NDVI have been well exported for further analysis. So with this simple example, we've seen how to automate the extraction of NDVI zone based on defined threshold thanks to the QGIS Python console. It's possible to enhance the script by incorporating multiple indicators, automating the collection of NDVI image in a cloud infrastructure, as well as their preprocessing before applying vector extractions.